Hey everyone, I'm Aryan, and I'm here to present Yearsley and Pothos' paper on Zeno's paradox in decision making. Now, when I think of decision making, the word choices really pops up in my head. Like, have you all ever wondered before, how do we make a choice? To what degree do the thoughts we are aware of have an influence on our decision making? Are they simply a result of our conscious deliberation, or is there some unconscious influence on these decisions as well? Now, these are some of the series of questions many thinkers have been pursuing for centuries. One influential approach to answer this has been the Bayesian probability theory on decision making. This model is intuitive to our understanding of human cognition, as it combines what we know before making a decision with new information to update our existing beliefs and make more informed choices. Though this idea has been validated in multiple studies, in some situations it is considered to be controversial, as it assumes we make decisions in a logical and consistent manner. And well, being a human myself, I can tell you that my decisions have often been influenced by many factors, such as my biases, which have led me to sometimes make decisions which in hindsight don't seem very reasonable. Another emerging theory for decision making has been the quantum theory model, the main focus of this study. This theory exhibits features like contextuality and interference that resonate with some of our intuitive understanding of cognitive processes as well. How is that? Well, contextuality suggests that in the quantum realm, measurements and outcomes depend on the overall situation and other measurements being made. Similarly, in our minds, decisions and thoughts often adapt to the surrounding context, leading to different interpretations or choices based on the circumstances. Similarly, a quantum interference is a quantum phenomena where waves interact to reinforce or cancel each other, drawing a relatable link to our cognitive processes. Like our thoughts and beliefs can also combine to strengthen convictions or clash to create uncertainty. This paper is based on the assumption that our cognition might have a quantum structure. So the authors made a priori prediction that opinion change will be slowed down by continuous intermediate judgments, a concept akin to quantum Zeno effect in physics. Sounds pretty fancy, huh? But what's this effect about? The quantum Zeno effect is a phenomenon which occurs when frequent observations of certain unstable particles stops them from changing forms. To help you all visualize this better, imagine that there's a shape in front of you. Now, the interesting thing about the shape is that as soon as you close your eyes and stop observing it, it starts to change its form again and again and again and again and again and again until you open your eyes and start to observe it again so frequently it's kind of creepy, and suddenly this shape just seems to be stuck as a square and it stops showing any signs of form change. The authors believe that if a similar phenomena can be observed in decision making, this would provide some compelling evidence for a role of quantum theory in understanding the mechanics of our cognition. Has this effect ever been tested before? Yup, but this study improves on it with a more structured approach and explores it differently. So, how did the authors measure the quantum Zeno effect with intermediate judgments? They set up an experiment using a narrative about a murder suspect named Smith. Most participants initially believed that Smith was innocent, after which, in a step-by-step manner, participants received 12 pieces of evidence that all suggested Smith is guilty. They split participants into 6 groups. One group's opinion on Smith was measured at the start and then at the end. The other 5 groups had similar measurements, with the addition of their opinion being intermediately measured at different intervals, which was the author's attempt to stimulate a quantum Zeno effect. What this means is that, for example, if a group's intermediate judgments were measured at intervals of every one piece of evidence, that would mean that every time they were shown an evidence, they would immediately be asked again to judge whether they believe Smith is innocent or guilty. The presentation order of evidence was partially randomized, aiming to achieve a more representative sample and mitigate order effect, where the sequence of information might affect participants' responses and skew the results. Notably, the experiment was conducted twice, purely as a replication exercise with different participants in each case. Data was collected using an online survey, in which the participants were asked to indicate whether they thought Smith was guilty or innocent when their judgment was measured. Following this, they were asked to justify their choice. For instance, if they said that Smith is innocent, they were asked to justify why, and a possible response to that could be like, that's because there's lack of evidence for Smith to be guilty. Based on this setup, the researchers aim to show how the initial opinion of participants on Smith's innocence will be less likely to change with an increasing number of intermediate judgment measures. To accomplish this, they developed a quantum probability model which they call the survival probability. It measured the likelihood that the initial opinion on Smith's innocence will persist over a sequence of intermediate judgments measures made. Now, this model had a few assumptions. The first assumption posited that introduction of new evidence could lead to a change in one's opinion state. However, this may not always hold true, as factors such as emotional attachment to certain ideas can significantly influence the likelihood of altering one's opinion. Secondly, imperfect judgments. The model assumes that inaccuracies can occur while making judgments, for example, due to factors like a participant being in a rush to complete the survey. Lastly, the model assumes that judgments influence each other. In other words, how a person influences a situation at one point could impact how they judge it later. As the Bayesian probability model of decision making is believed to be more intuitive to the potential mechanisms of recognition, the authors also constructed the Bayesian probability model to help them with parameter fixing. These parameters relate to the assumption the quantum model makes about relationships between variables, which help them form more accurate predictions in realistic scenarios using real-world participant data. Now let's dive into the results. The two graphs here show the same concept using different participants. Both graphs show the initial judgment right around here, followed by intermediate judgments for the 11 pieces of evidence measured according to the different groups. The solid line in the graph represent the quantum probability model, indicating the likelihood of sustaining the judgment that Smith is innocent with increasing intermediate judgments. It refrains from descending anywhere closer to zero, which is a crucial point indicating that the participant's judgment regarding Smith remains consistently innocent as a whole rather than shifting towards guilty. In the second experiment, a similar trend is seen. However, a dip emerges right around here on a single intermediate judgment made. This dip is attributed to the uneven distribution of participants across the 6 groups, and consequently, the weightage given to those whose intermediate judgment was only measured once was relatively smaller compared to other intermediate judgment measures. These findings demonstrate a quantum Zeno-like effect in decision-making as participants' judgments remain stable amid intermediate judgments. However, as portrayed by the dip in experiment 2, these measurements are not perfect. Now, how does all of this relate to the consciousness research? Well, when it comes to decision-making and consciousness, the whole concept of free will really erupts in my mind. I find that the decisions in our mind are like constructs, and research studies like this one that are working on finding a mathematical model to predict the process of our mental functions can help us in forming more concrete ways to operationalize them. It's so fascinating to see that there is a potential relationship between the certain behaviors we find in particles from quantum physics and our human behavior. This therefore offers us a glimpse of how we can potentially replicate our cognitive processes as equations. Nonetheless, many more trials and errors are yet to be made to ascertain whether mathematical equations can truly help us determine the mystery behind the concept of free will one day and help us understand where possibly our conscious, subconscious, or unconscious effects can come into play when we make our decisions. Thank you for watching.